In this video, we'll be going over indefinite integrals and some basic integration techniques. An indefinite integral is an integral that does not have bounds. This means that we're finding an antiderivative with a general solution. So let's consider, if f prime of x is equal to 2x, what could f of x be? So maybe our instinct is to say that f of x would be x squared. And that certainly could be the case. But we could throw out other options as well. We could say, what if f of x was x squared plus 1? That would surely have a derivative of 2x. What if I had f of x equals x squared minus 10? Or f of x equals x squared plus 300? All of those functions have a derivative of 2x. So we have to kind of say to ourselves, well, how can we write a solution that accurately represents this idea? So if we are integrating 2x dx, we're going to say that that answer is x squared plus c, where c represents that arbitrary, that unknown constant that could be there. In this video, we're going to use the reverse of power rule, basically integrating polynomial functions like that one. But we're also going to be talking about some transcendental functions. So I'm not going to read through all of these here in the video, but you can see here are some integration rules for exponentials, for logs, for trig functions, as well as inverse trig functions. All right, let's try some practice questions using our new information on indefinite integrals. So first we have the integral of sine x plus 2x dx. We're going to integrate each piece separately. So the antiderivative of sine x is negative cosine x. We have already talked about the antiderivative of 2x, that's x squared, and then we're going to put plus c at the end, and that's our answer. Now keep in mind, while not necessary, you could always check your answer by taking the derivative of each term. So the derivative of negative cosine would be sine, the derivative of x squared would be 2x, and the derivative of that unknown constant would be 0, and we can see that we have back our original question. All right, for number 2, we're looking for the integral of 5x squared plus 3x minus 2, and that's really a minus 2 to x to the 0 power over there. So we're going to use the reverse of power rule. We're going to add 1 to the exponent and divide by that same number. And we're going to get 5x cubed over 3 plus 3x squared over 2 minus 2x. You could write that as 2x to the first over 1, but certainly not necessary. And then, of course, we're going to put our plus c at the end. All right, number 3, the integral of 3 to the x. When we integrate exponential functions, recall that that rule from the previous slide or earlier in the video. This is going to give us 3 to the x over the natural log of the base, which in this case is 3, plus c. Number 4, and a lot of these take memorization and practice too to get used to knowing, okay, when do I do this versus that? So a good example of that would be number 4. Okay, I can recognize that we basically have the derivative of inverse tangent here. 1 over 1 plus x squared is the derivative of inverse tangent. So that means the antiderivative of 1 over 1 plus x squared is inverse tangent of x. And then I also have here the antiderivative of 1 over x is ln of the absolute value of x plus c. Okay, number 5. We're integrating the cube root of x. We could rewrite that first to help us out and make it a little easier as x to the 1/3 power dx. Now using reverse power rule, I'm going to add 1 to the exponent. I can divide by that number, but since it's a fraction, I'm going to instead multiply by the reciprocal. And I could even clean that up a bit. So this is going to be 3 times the cube root of x to the 4th over 4 plus c. Number 5, the integral of secant x tangent x dx. This one is honestly memorization. I know that the derivative of secant is secant times tangent. So the antiderivative of secant times tangent is secant plus c. Number 7, we're looking for the integral of 1 over The square root of 1 minus x squared, I recognize that as the derivative of inverse sine, and plus c. A lot of these, again, take memorization, particularly those inverse trig antiderivatives. Okay, number 8, we have a polynomial function, so I'm going to do reverse power rule. 4x to the 6th over 6 minus 3x to the 4th over 4 minus 8x squared over 2 plus c. If we wanted, we could clean this up a little, so 2/3 x to the 6th minus 3/4 x to the 4th minus 4x squared plus c. Number 9, 3 over x. We're integrating here, so I like to sometimes think about that as 3 times 1 over x. The reason that is because I know that the derivative of natural log will give me 1 over x. So when I integrate 1 over x, I'm going to get back that natural log. So this is going to give me 3 natural log absolute value of x plus c. With natural log, when we are integrating and we are putting natural log as our answer, we have to remember to put absolute value bars around whatever we're taking the natural log of, just due to the domain of that function. Okay, number 10, mix of an exponential and a polynomial. So I have e to the x plus 6x cubed plus 2. And recall, this is really like 2x to the 0 power, right? X to the 0 or anything to the 0 is 1. So this is going to give me e to the x plus 6x to the 4th over 4 plus 2x plus c. If we want, we could rewrite that 6 over 4 as 3 over 2, and that would be equivalent. Okay, number 11. Pi cosine of x, we are going to find the antiderivative of that. Now, pi, remember, is really just a coefficient. It's any number. Pi is not a variable. Pi is a number. So you could think about this the same way you would integrate 2 cosine x, for instance. You would copy down the 2, or in this case, pi, and basically just integrate cosine of x, which would give me sine of x plus c. Number 12, this one is another one of those where really just memorizing becomes very helpful. It also could be helpful if you wanted to rewrite this as 2 times 1 over absolute value of x, radical x squared minus 1 dx. That might help us recognize that that is basically, this whole piece here is the derivative of inverse secant. And then, of course, plus c. All right, just a couple more in this video. For 13, this looks like a product here, but we cannot find the antiderivative of a product. So what we have, or at least not using a reversive product rule. So what I'm going to do is I'm going to rewrite the integrand here. So I'm going to FOIL or distribute, however you would like to think about it. So x squared minus 3x plus 2x minus 6. We could rewrite that again as x squared minus x minus 6 dx, and that would give me x cubed over 3 minus x squared over 2 minus 6x plus c once we integrate. All right, and similarly on this last one, I have to simplify this a little bit before I could actually find the antiderivative. So I'm going to divide each term by 3 over x. So think about it like this, x squared over 3x plus 6x over 3x. If I simplify that, I'm going to get x over 3 plus 2. You could even rewrite that once more. I mean, sometimes rewriting a few times can help make it look a little easier. You could rewrite that as 1/3 x if you'd like. And now I can finally integrate here. So I'm going to have 1/3 x squared over 2 plus 2x plus c, or x squared over 6 plus 2x plus c. If you head to the next video in this playlist, you'll learn about some more advanced integration techniques.